Okay, welcome back THS chemistry students. Today we're looking at calculating average atomic mass. You can write this down in your notebooks, and hopefully by the end of the video you have an idea how to calculate the average atomic mass of an element. Okay, the average atomic mass is an average of the mass of all the naturally occurring isotopes of an element. So the number you see on your reference table is an average number. So you have to look at all the isotopes that occur of an element, and we got to average them together. Now, we don't just add them up and divide by 2, because they're not all occurring at the same abundance. So what we need to do, the average atomic mass of an element is the sum of the masses of its isotopes, each multiplied by its natural abundance. Okay, get those two down. Okay, so carbon's relative atomic mass is 12 atomic mass units. Okay, that's why the number is rounded to 12.011. Now, that's because carbon's atomic mass units comes from 6 protons and 6 neutrons. So 6 plus 6 is 12. So in an atom of carbon 12, that means there's 6 protons and 6 neutrons. Now, carbon's unique because every 99 atoms out of 100 carbon atoms has 6 protons and 6 neutrons. Therefore, the mass is of 12 atomic mass units. Okay, therefore, carbon 12 is 99% abundant. Now, that one atom that's not carbon 12 could be carbon 13, carbon 14, okay, where the neutrons would be changing. Okay, so they would have different atomic masses. So we have to average them all together. Well, the mass of one atomic mass unit, you got to remember, which has a mass of a proton or a neutron, comes from the mass of the carbon atom. So 1/12 the mass of carbon 12 is the mass of one proton or one neutron. Okay, carbon 12 is the standard for atomic mass units. So, okay, what happens if not every atomic's mass is 99% of one isotope? All right, chlorine has 2 isotopes. Okay, they have chlorine 35 and chlorine 37. Okay, the exact mass is 34.969, and chlorine 35 exists as 75% of all the isotopes on our planet is chlorine 35, where chlorine 37 is about 24.22%. Okay, so since they're not equal, we can't just add up the masses and divide by 2. If we want to find the average atomic mass, okay, we got to take into account the percent abundance. All right, so how do you find a weighted average then? Because this is what we're doing. We're doing a weighted average. Okay, so calculating the average atomic mass. This is how you're going to do it. All right, I gave you chlorine 35 and chlorine 37's data. So this is what you're going to do. To find the average mass, you got to take the mass of the isotope number 1. So for chlorine 35, it was 34.969. And you multiply it by the percent abundance divided by 100. Okay, so that's your number from your first isotope, number 1. Do the same thing for isotope number 2. So isotope number 2, chlorine 37, is 966 times 24.22. And then you divide the whole thing by 100. Okay, now, you get an answer for both isotopes and you add them together. So the first answer was 26.50 plus 8.95. You add them together and you should get 35.45. Okay, so check your answer with the atomic mass in the reference table and they should be close to the same answer. Okay, the sig figs might be a little different, but you should have very close to a similar answer. Okay, I want you to do this one. So, this is going to be practice. Calculating the average atomic mass for boron. So, you got isotopes, 2 isotopes here, boron 10 and boron 11. Okay, the exact mass for boron 10 is 10.012, and the percent abundance is 19.80. Boron 11 is 11.009, and the percent abundance is 80.20. Okay, now this formula is not in your reference table, so you got to memorize how to do this. So, take the mass of the first isotope, which is 10.012, multiply it by the percent abundance, divide by 100. We divide by 100 because you can't multiply by a percentage. Okay, so 19.80 is a percentage, so that's why we divide by 100. All right, so you have 10.012 times 19.80 divided by 100 plus, okay, go to the second isotope, 11.009 times 80.20 divided by 100. Okay, do the math out, show your work. Okay, now check your answer with the one that's on the reference table. So go to boron, it's atomic number 5, go to the reference table and check your answer. This should be the same. Okay, let's do another one here. Now this one has 3 isotopes, so nothing changes. All you got to do is do the same exact thing for 2 isotopes, 3 isotopes, 8 isotopes. It doesn't matter. You just add all the values together at the end. So, mass isotope number 1 is 23. I give you a lot of sig figs here. 23.985045. Okay, multiply by the percent abundance, divide by 100. Okay, do it for each isotope, and then add them together. Okay. Again, check your answer. Magnesium in the periodic table. All right, so it should be, look at magnesium. Magnesium is atomic number 10. Number 12. Check your answer. All right, set up your work, show your work, and you should be good. Okay. If you have any questions, we'll go be checking this tomorrow in class. Have a good day.